bench. Okay, I should be live. Let's wait a couple of seconds until I hear the feedback of the audio. Should take around 30 seconds. Schedule. Okay, I do have the audio. Takes 30 seconds, so it is a bit delay. Oh, the stream today, again in my medical devices tiered out bonanza, we will tear this machine down. This is a blood sample analyzer. This is the Afinion AS100 Analyzer. And it is pretty heavy. But before we take a look at that, we will take a look at other devices I just had laying around, but which are a lot smaller and probably not that interesting. So we will start with this one. Let me switch off the light. Up, light is off. A small light. So this is the HemoQ HB 201 Plus. Yeah, same thing. And made in Sweden. I think this is also a blood analyzer, but I think HB stands for hemoglobin. So you put the sample here and then you measure how much hemoglobin you made, maybe to measure the iron content, or that would be my guess, is to measure the iron content. And it's very used, or I've seen it very often when you donating blood. So they can verify if you've eaten enough and if you won't fall because of the blood loss or lose consciousness because of the blood loss. That's the machine, and it's quite portable, pretty simple. We have 3 interfaces, external power. I don't know why there's a jack interface, and USB probably to read to the computer, but the measurement will be on the display, and I think this is what it's meant for, to be portable and on the display. So let's just take it apart and let's have a look at the inside. So you see, portable, just with batteries, and they are pretty dead. Can I switch it on? Oh no, they're not dead. 106. Okay, it does some measurements. The batteries are still okay. HB. Let's put it in. So there's a sound notification. Maybe the sound notification, you can connect the speaker here or some headphone, so you can hear if this buzzer doesn't work anymore. Okay. So detect if there's no sample. That's already good. You see, there's only one tiny hole. Let's zoom a tiny bit. There's a tiny hole just there. And let's remove the other cam because we won't need it for now. Where is the other cam? This one. And we don't need the power measurements yet. Well, we can leave them. Yeah, we can leave them. So here is where the sample goes. There is a small window. I think it checks here, but how does it check if something is inside or not? Now it's trying to do something. Does it complain? Let's wait a couple of seconds. Okay, 0. So it doesn't complain. It doesn't verify if there's a sample. It just verifies the emissivity. And then we'll have a look at how it still works though. This machine still works. You just probably need these samples. I don't think these machines are very expensive. They are bulk made devices, but we need to find the screws. I hope there are screws. There are none here, so they are probably under the feet or under the sticker, but on the sticker wouldn't be sufficient. So first, not under the feet. None of the feet. No. No. Okay, so under the sticker. Yep, there's one here. Let me check if I can break the seal and open it. Yep. Nope. Is it one? It looks like, but I don't know if it is. I can't break through. Here, yeah, there's a tiny metal shank, but that's the metal of the sticker. So here, a metallic sticker. Okay, maybe because it lasts longer than other kind of stickers. I'm not sure when they use metallic stickers. Okay, there's nothing. So it was just a small cavity, but no screw there. So apparently there are no screws. It's only fit together, and this is where you can see that it's probably not the first iteration, and try to make it as cheap as possible, because screws are very expensive, simply because it's metal and because you need an operator which screws them in. And here you just need a machine clicking the devices together, or you can have an operator, but it takes a lot less time than screwing things together. Okay, that's the first part. I can't get this to, here, maybe there's some locks right here. Yep. There's something locking here. I don't know what. There's a last lock. Do I see a screw if I move it inside? No. Where is this last lock? Damn it. What if I just unlock here? It's not sufficient. So there is a screw here. No. This is the lock. Now I see it. Just right here. That's weird. Having tabs right there, maybe because of the door. Yep, that was it. Maybe because of the door, but it's quite unusual. Yeah, there was a tab here also, but I've never seen. I normally know you have put tabs in here, but I've never saw that you have tabs accessible from the outside. So it is serviceable. That's surprising. Okay, that's the machine. That's inside here. There is a black compartment. This is from the outside, maybe to reduce the amount of light. Even an internal serial number with a can. What's here? Something is canned. This is unexpected. Do not open. We will open it. We won't follow you. So, what markings do we have? HB 201 plus and 2 serial numbers, not the same one. And this is from, is there a date code somewhere here? Here. There's an Optica. So this is ready-made optics apparently, which they just arrange. Date codes here. Oh, they have a microprocessor or EEPROM for with the version, and then 120828 29 August of 2012, I think. So this model is 10 years old, but I think it's still good enough. I don't see why it wouldn't be. What we already see here, so this is, I only see this processor. Yep, this chip has a weird marking. Let's zoom this way. I don't know what this is. Let's remove this measurements. We don't really care about it. So here we have the backup battery, probably for the last measurements, and you can read out the last measurements over UART, over USB. Now I'm saying UART because here you see there is an FT232BL. This is a USB to UART converter. So the USB directly goes to the USB to UART converter, and then it speaks UART to the microprocessor, which is right here in this socket. This socket of microprocessor is quite old style, where you had this kind of, I don't know how they're called, it's not QFN, it's not QFP, it's, I don't know, with the tabs on the outside. You don't do that anymore. Well, this is a crystal clock, so it keeps time, keeps track of the time, so you can program the time and then it can save the measurements. So it has some SRAM or some EEPROM. Let's see if we find something here. This is where we see it. Here it's written 24C64. This is a EEPROM. This is an I2C EEPROM. So it's probably putting the measurements in here. And this battery is just to keep track of the time. Maybe here there are also some calibration values. This is, I don't know what this is. This is probably an op amp because we see the two lights, either a light emitter and receiver, two light emitters, I don't know, which go inside here, probably two light emitters. Then on the side we have this switch. Oh, this is a weird mechanism. It gives kind of a springy action, that's not bad. And there is a window on the side, so this opto barrier just detects when it's inside or out, or when this is broken. So on one side we have an LED, on the other side we have a photo transistor, and this way we know when the door is closed. I would have, I love the spring action, it's quite nice. So you don't need a spring. I would have put a micro switch somewhere, but then we wouldn't have this this really nice snapping action. Although maybe with another series. Now I still wonder what is inside this can on the bottom. How will we remove it? It's soldered on. Do we want to? Let's switch on the desoldering gun and we'll probably unsolder it. Let's try to see what kind of microprocessor this is. I see some marking, so they didn't scrape the marking. I think any microprocessor could do the job, but what do they use? This is an NXP part. No, National Semiconductors. NH152ACE. What is this? NH152. Let's have a look. NH. Let's make it here so you can also see it. NH152ACE. And while it's searching, let me open this. Okay, nobody knows about it. Did I read it wrong? No, NH152ACE. And this is the National Semiconductor logo, as far as I can see. But this can't be just an... No, there are too many pins. This is a microcontroller. Here we have the clock for the microcontroller. Here, I don't know what this is. DS1302. Oh, this is an RTC. This is the RTC oscillator. So this chip doesn't have a built-in RTC. It uses this external RTC, and this external RTC uses this crystal clock. We also have a clock, but this is for the FTDI driver. This is probably less powerful than the FTDI driver in terms of megahertz, but it's just reading a couple of ADC samples. You don't expect too much, but nobody knows about this chip. No. NH, National Semiconductors. National Semiconductors. National Semiconductors. I think it. Yeah, this is National Semiconductor, but I don't think this still exists. Like, oh, it does. This manufacturer still. No, it's Texas Instrument now. So we probably won't find any data sheet. Fuse holder. No, there's nothing like it. Data sheet we will not find, and it's only 10 years old. And we don't find any data sheet for that. Well, quick look. National Colleague NH152. Why doesn't it exist? This is really weird. Data sheet, no gen. Okay, nobody knows. Oh, I'm thinking if we look further, we would have could find it, but who cares? I'm not going to reverse it, and I want to try to remove it to show you. It's with this one maybe. Normally you should have a special clamp which clamps on the sides, on the two sides, and then can lift it. This was very often done for EEPROMs or for BIOS on motherboards. I don't have this. This is beyond when I started electronics. This is very crusty. I won't be able to make it without the right clamp. Oh, oh wow, it's in there for good. Now I'm breaking the socket. Yep. So this is, I don't remember the name of that. I've never used them, where you have this J lead and then it plugs on the side, and it was holding very well. And this allows you to actually program this separately and then to put it on here, and we can actually see that there is no programming port. So they did program this on the programming sockets, and then they insert it right here, probably like an EEPROM, because yep, there are no programming points. Or maybe they are here, but I don't think this will be programmed in circuit. Else you wouldn't spend so much money for socket. If it's in circuit programming, you would just solder the thing directly on it. But now let's have a look at this device. Now there's a screw here. Screwdriver with the right bits, and no, not the right one. This will be the right one. This is the right one. Up. And I'm still interested to see what's behind the can. SH1. I don't know what SH stands for as a reference designator. I wonder if this battery is still okay. So let's have a look. So now I can re-enable the measurements. Let's check if the battery is working. This is plus and the minus is on the other side. Wow, 3.3 volt. The battery is still running fine. So this still has the time. Not bad. I won't salvage it. And here is a second screw. I think that's it. SH1, I don't know. Maybe there's a reference sample. I don't know. We will probably have a look. So once I managed to open it, but it doesn't. Oh no, it does work. Okay, I have to remove this gunk. This is holding back. Oh, they even have some, don't know how they called, eyelets. Need the screws. This is not hot melt glue. I don't know what this kind of gunk is. Who cares about it? It's at here. I will never put it back together. Up, 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 up. These are just two LEDs. So somewhere else is the reflector. And maybe there are two different lights. We will check afterwards. Okay. Oh, two-sided. Wow, that must have been expensive. So here, so this is just an LCD, a custom LCD. There is even, you can see it on the back, on this side maybe. Here, this chip. This is the LCD driver. We won't have a look at it. It's nothing interesting. There are plenty of it like that. I think it's just controlled by this microcontroller, by this one, which I still don't know what kind of microcontroller it is. But see, surface mount on the other side with a huge footprint. This is soldered by hand. Okay, this is not soldered by a machine. And they probably put the version here. I don't know if this is a transistor, U something. I don't know what it is. It's probably temperature sensor. Okay, now it becomes a bit clearer. Here we have the light. We can probably see the light pipe. Do not remove. Well, let's remove it. This way we can see on the inside. And we break the whole calibration. Wow. Something is holding it back. Come on. Ah, do not open. Here. There's a screw here. This is holding it back. Oh, they take it pretty serious. And that's probably the most expensive part. This optics. Having at least the development. I don't think the development for electronics is that expensive. Okay. So, yep. Oh. Okay. Ah, now I get it. Here we have, this is just a light pipe. You have the two LEDs. All the light travels through the two LEDs up to here. This is a very weird light pipe. I would have expected something which goes straight, but no, it circles and then goes back in. This is complicated. I don't know why you would make it so complicated, but make it resist, I don't know. Maybe to have different grating. We'll have a look at the LEDs if they shine different lights. I expect that this is the bit is screwing my, oh, it's breaking my, the screw is breaking my bits. Yep, it's done. This bit is not from this world anymore. It was also a chip bit, so. They do like two different LEDs. One has a filter, does it? Let me get another screwdriver. I should have some of them. Probably this one. Too small, too small. Larger. Up. Yep. Okay. So this is just a PMMA light pipe, and then there is a, okay, they have a lens also, and they have some lens effect right here. This is quite a bit of engineering. And up. This one side is open, the other side is open, and here there was something, this flew off, and this was in front here. And this is a filter. I don't know what kind of filter it is. It looks very greenish. You don't see anything. It's, I don't know, kind of, is it a kind of special infrared filter? Now the LEDs look the same, but we'll measure the forward voltage and see if they are the same. Up. Diode test. Wrong way. 1.8 volts. Yep, infrared or red. Let's see if we see something on the other side. Ah, maybe red. One is red, one is infrared. One way around. No, one is green. Yep. There's a green LED for measuring, and one is not visible. Maybe it's visible to the camera. Is it visible to camera? But first, by eye, I don't see anything. Does the camera see something? 1.2 volts. I don't know what kind of LED it is. I will guess infrared. Yep, the camera sees it. You see this glow? I don't see it by eye. So this is an infrared and green. So this is really like a blood oximeter. Okay. We see often blood oximeter to measure just how much blood flows in your vein, and then this way we can read your heartbeat without having two electrodes. You find it in fitness tracker where it reads it here. When you have a watch which reads it here, plenty of fitness tracker have it, and they use infrared and green, so it's the same principle here. And then so there's the light pipe, and the light pipe with the filter. So this is probably a filter for the green, and they want just a particular green and not all kinds of other green. So the light pipe puts it back here. This goes through the sample, which is on this door. You see it goes through the sample, and then it goes to this receiver. This receiver. Let's try to have a look at what is inside here. So there's a lens, but what is behind the lens? It's probably just an optical receiver, but we'll see what this is if I manage to unsolder the tabs. Did it work, or do I have to? Oh, it works on what side? I don't think it worked on the other one. No, it didn't. So this is why there's a can, so to shield against the light. But I would have expected not a metal can, but a plastic can. Ah, but you can't solder a plastic can. This is probably why they put a metal can. So let's put a tiny bit of force while we are on soldering. Or not. Yep, this side is completely unsoldered. The other one I'll probably want because I don't have the right access. I could use how is it called? Oh, it worked. Oh, unsoldered. Why? I broke the pad. It's not very clean, but it is unsoldered, and now we can have a look. So some gunk again. Wow, this is a process, and there is a 555 timer. Oh, okay. A 555 timer. It's probably to convert the intensity back to something else. So what is this? There is, oh, it's hard to see. Try to focus. You see the bond wires? Here is a bond wire. This is a light sensor, a huge light sensor. So it detects very, very tiny amounts of, I don't know what color. It's probably the same sensor you have in your fitness tracker, just in huge with a lens. But I would expect that now the sensors are probably a bit better, and you don't need, or you don't need that big, and you could use probably use a fitness tracker for the same thing, but then it's hard to make the certification process and so on. But that's it. There's not a lot behind that. There's the buzzer, there's the two buttons, some other things, but with the 555 timer, it's probably changing the intensity to something else. So first thing is done. Let me clean the bench so we can go to the next teardown. How long did it take, this one? We are at my stream. Why don't you stay on the left? Up. 30 minutes. Okay, a bit longer than I expected, but that's okay. This is all plastic. This can be recycled and go into plastic bin. Up. This is in the electric bin. The battery bin. Up. That's plastic. Now, so this was the easiest sensor. Let's switch to the next easier one. And it will not be the blood analyzer first. I have another sensor which doesn't fit. This one. The Urisys 1100 by Roche. I think this is urine analyzer, but it probably has the same principle. So here we have the markings on the back. Urices 1100, external power, no batteries in here, by Roche. I think Roche is one of the big players in pharmaceuticals. And we have screws on the back. Let's have screws. And here they just like, yeah, I don't have, oh, you could switch power on, put 7 volts. I don't want to test if it works. It probably works. Serial interface, barcode reader. Okay. And here we have a label printer. They put some gunk on the other hand, just on one, to verify if it's opened or not, and to put the seal. It's cost. It's good for the cost. You just need to put one. It's just funded on. So this is probably mass market. Made in Germany. In Hungary, no. Made in Hungary. Roche is German. Okay, it makes it hard. That makes it super hard to unscrew this gunk. It's not the kind one. How does this fit in? And if they have, nope. So this is probably just to check if somebody opened it or not for insurance claims or warranty claims. No, still not enough gunk removed. I can't access the screw. Let's continue removing. Now it's all removed. Now we can have the screw out. Up. This is crush up. Do we have a screw in the middle? I don't feel one. Da-da! Oh, okay. This is a bit more complicated. A lot more complicated. Why the hell does it have a motor? Why does it need to drive something? It drives the sample inside, so you... Okay, this is weird. There's a magnet here. I don't know why it's supposed to activate. When you slide it in, apparently there's a motor which takes it in. It would have been nice to actually test it. Let's try to test it. Probably still works. Nope. But there's nothing I can do to test it. I don't have any sample. Let's not test it. I don't have any samples which I could slide in. Wow, but it really... So there are magnets. There's a magnet here. There are two long magnet bars here, or metal bars. Maybe they're just metal bars. Let's check. No, they're magnets. It's not just for rigidity. I don't know what the magnets are doing. There was the time code on the back. No, there is none. There is here a time code, September 2011. So this is 11 years old. Here, what do we have? We have some, this is the input for the barcode reader. This goes straight there with a bit of protection. This is very probably the voltage regulator. Yeah, there's the voltage input here. So it operates at 5 volts. This does the 5 volt regulation. Here we have the RS-232 port. These are probably the 2 level shifters for input and output, and they don't use a max, something like that. Here we have 2 more. Ah, these are the MOSFET drivers to turn the motor. Ah, still would like to try it out. Let's try it out. But it needs a lot of power. This is, can I use this plug? Is it a 5? No, it's not. Ah, damn it. It's not a 2.1 millimeter plug. It's 5.5 on the outside, but it's larger on the inside. And I don't know if I have the right plug for that. I hate this non-standard. Well, it's also good that there's non-standard plugs. Barrel jack. So I have a box with plenty of barrel jacks. Maybe there's one which will fit. This one doesn't fit. But they're all small, they're not that large. This one doesn't fit. We could tap on, wait, no, but if we open it, we could solder points onto it. Then tap on the inside. This one is not the right one. This one is not, has a plug inside. No, I don't have any. Which fits. Nope, nope, nope. Nope. Do I have a 2.5 millimeter? I think the internal is not 2.1 but 2.5 millimeter. Maybe I have a 2.5 millimeter which fits. Let's check. Where is my box? With not banana, not TRS, PNC, Zebra, USB connectors. I still have one. Okay. Don't know what it's doing here. Where is it? This one. Up. Do I have a, no, that's 2. Maybe 2. No, that's 2.1. That's very probably 2.1. Yep, 2.1. No, I don't have the right plug, so we won't be able to operate it. Up. And so these are the 2 drivers. This is probably half bridge driver. This is, oh, there are some ground. Now we can zoom a tiny bit more. Some ground pins, some send, and there's probably a receive. This is a buzzer. Okay, so we have plenty of boards. We have this board, we have this board, and this board, but they are all separate. This is just for the motor. Not only just for the motor. This is the adapter. There's nothing that interesting on here. Nope. Let's remove it and put it in the right bin. 1, 2, 3, 4. Here, DTR, RX, TX, ground, send. Yep. We have all the pins labeled in the copper. So maybe they wanted to make it a bit cheaper. I don't have any seal screen because everything is in the copper. This is how you solder a cable with some wires, with some metal wires. Okay, this is, one is at least sleeved, the not ground one. But it's the first time I've seen it done this way. And on the other side, probably this is the date code, 20th week of 2011. Nothing interesting on there. Bye bye. Up the motor. It's probably a bit more interesting. Let's take it apart. You can see what I can't see. You are above. So this has plenty of 6 connections. This is very probably a stepper motor. Why 6 connections? I don't know. 5 volts, yep, stepper motor, because it gives the angle 7.5 degrees. So per step, it's 7.5 degrees. Coils are 12.5 ohm, and it's a 5 volt stepper motor. Let's keep it. We will use this stepper motor for other projects. Up 1, 2, and does it do anything else than just roll the sample inside? So this, no, it's just a roller. So on the front, this is a free wheel roller, so there's nothing turning it. And on the back, this rolls here. This is also a roller, but here on the side there is this gear, which probably pulls the sample inside. And in here, this board does the measurements. 1, 2, we see that there's a LED on the side. It shines from the side and looks on the top. This is okay. It shines on both. Ah, no, it doesn't shine. This is again an IR barrier, like we seen on the other one, where it detected if the tray was closed. Here it detects if the sample passed. So there is one infrared LED and then there's one phototransistor. And here you see it. AK anode cathode. This is the LED. Emitter, collector. This is the phototransistor, because the base is simply the infrared coming from this. So this is just that. This is just a photo barrier. Doesn't do the optical measurements. And what is surprising at this, okay, you see this shininess? So this board is coated, but it's the only coated board. The other ones aren't. Probably because it gets in contact with the urine. Okay, let's try to lift this so we can see the butts. Is there a screw which I don't see? It doesn't. Okay, it does lift. Ah, I need to remove the LEDs on the side. Glued, so they won't be removed. They will be. Up, 1, 2. Now we can switch the boards. Okay. Wow. So everything is done within this package. And you see plenty of pins. So there are probably multiple LEDs and multiple receivers. We'll have a look at that. Yeah, this is a board-to-board connector with some tape on it. What is this? I think this there are so many pins here. This is 2.2 times 5. Yep, these are 10 pins. Probably they go directly, all go here, and then to drive this our infrared barrier. And we have lots of, I would guess these are inline coils, inductors to prevent the rush. I don't know. They don't have the color of a capacitor like this one. They don't have the color of resistors because they are too large. Maybe, don't know. But the sensor, okay, I can't. Can I pop open this sensor? Oh no, I can't, but I want to see what's inside. From the back I probably won't be able to, but I'm heating the diesel ring gun. This is a ready-made module to measure I don't know what, and probably I don't know if they will use all the potential of this module. Oh, no, I can't manage to break it open. Damn it. I don't want to get the Dremel out. You see it on the side, okay. Okay. What is it? Just that? This is weird. Now I get it. if you look on the side, you see all the side are different diodes. So on the sides you have the diodes, and in the middle you have this photoresistor. I think this is, I would guess this is simply a photoresist, phototransistor or some kind of light circuit, and it is calibrated. And then depending on the lights which shines, it just, in the different lights, it determines the spectral absorption of the liquid. Let's have a look if we can make the LEDs glow. Yep. So here we have, it's hard to show you. Let's try to show you this way. This LED doesn't work. Okay, this is not an LED, or this is a white LED which I can't make shine. Ah, no. Contact were just not good. No, I can't make this LED shine. But I was able to make this one shine. But you can't see it. So there was a green LED. Damn it. How can I test it? I could put some this on the side. Can try with up leads to my bench power supply, put a maximum of 3 volts, and what's more important, the current. Let's limit it to 20 milliamps. 20 milliamps. Are you seeing what I'm seeing? 20. It should be 20. Okay, now 20. Now it's on. And now I can plug the things and try to see the light. Okay. This one is orange. Next one is, so this is ground. This is not ground. This one is green. Okay. Green, but it's probably not kind of different kind of green. This one is orange. Okay. This is just green and orange alternating all the time the same. That would be weird. Green again. So it's not only about, it's not only about the so many different colors. Yeah, orange. You saw the orange, and the last one is green. Okay, why multiple of them? So this way you, yeah, green again. This is to get some uniformity. So you spread the different lights to get some uniformity. Okay. And in the middle, I still think there is a photoresistor. And you just, so previously in the blood analyzer, hemoglobin analyzer, we saw the lights were green and infrared. This one is kind of orange. Well, makes sense for piss, urine. And then green. Oh, this is super hard. This doesn't lift off. I would love to see the inside. I want to see what the sensor is. It doesn't budge. No. I don't know how they welded or they glued back the two parts here. let's see if I desolder the part. What it tells me, will desoldering work? Because there is this coating. Not familiar. No, it does. Okay. I know my desoldering gun is far too hot and it damages the board, but at least it works fast. And now it looks like more damage because there's the coating. So, come on, video. Okay, I'm back. I'm very sorry for that. OBS died again without me seeing it. I don't know why it dies so often. It never did before. I would have to pay a bit more attention to it. Let me enable the audio and put the audio loud so I can hear you. And this way, if I don't hear anything, it doesn't work. So, really quick summary, it was that we took apart the sensor, which we blocked, and there are LEDs on the side that we saw, and in the middle there is a, in form of an LED diode, there is a receptor, and it's not just a light dependent resistor, it's really, I don't have it anymore, I've threw it away already. It's not just a photo diode, it is probably a photo diode, I don't know what the name is. But it's not just measuring the intensity. It's a more complex. But the idea is that really they shine LED and then they measure how much comes out, like they did for the hemoglobins, just with different light and with different sensor. But what I was wondering is, so this we took apart the next board, and on the next board we saw that this is just the button to start the measurements. These are the buttons on top to select anything. This is the interface to the LCD. We'll come to that. We didn't finish it, and this is a custom board. And what I was wondering is that here is a connection to this side, and beneath the paper of the printer there was this chip. There was written software 5.6. Now I broke it already, but SV 5.6. So this is the version number, and they encode the version number. So what you could do is just bridge the traces or cut the traces, and depending on that you know which version you have. Or you put a resistor, and depending on the resistor value you determine the software version, the software version number, or the hardware version number. Probably more the hardware version number than the software version number, because you are programming the microcontroller, so you know the version number. But here they have something else, and I don't know what this chip is. This is an ATML H104. I would have guessed some serial EEPROM, but it might be even an authentication chip. Although for these kind of devices, I don't know if there's so much counterfeit things. Let's have a look. ATML H1042 GB. Let me also show you what I'm doing. 42 GB, wrong one. 42 1042. No. Okay, this, yeah, an Atmel part. Kind of expected that, but what kind of Atmel parts? I don't like HK inventory because you never know what this is. HTML1, yeah, this integrated circuit. What kind of circuit is this? Jointronic HTML H. probably don't have any data sheet, and this is just, yeah, this is just Java. Hate that. JavaScript on some other date. Yeah, this is the right chip. They know it's sub 8. That's it. Yeah, sign in. I hate that. This is a very old chip though. Serial EEPROM. Ah, it's just EEPROM. So you're only seeing one side. Oh, sorry. Let me just check. Screen this way? No. Full screen. Okay, here. Serial EEPROM. Well, it's not one of these devices. Maybe the marking is different. But I would guess if I land on this chip, 104. No, it's not there. Yeah, I would guess just a serial EEPROM of kind we don't know. Not HK inventory, Advanced Corporation. Yeah, HK inventory, Procure IC. Let's have data sheets. Screen. Data sheets. It's not an 8. Or is it? No, it's not. It's something else. I will block HK inventory. Up, HK inventory, block site. Up. Okay, now all HK inventory should be done. That's not the right device. We don't want a sum. Here again, HK inventory. Come on, HK inventory block site. Yeah, it's probably just a serial EEPROM. Let's leave it at that and let's continue because this is not the main thing we want to hear about. And now we have here, so this is just a thermal printer, a really compact thermal printer. Never seen that compact. This is ground wire for static discharges, and you don't see what I'm doing. Bench, and we don't need to see this. Okay, thermal printer with a micro stepper. Yeah, 4 wires, so it's micro stepper. And here we have the main board. Again, we have a clock for the very probably to keep the clock running. And here we have the crystal quartz. This is probably yep, DS1302. This is the RTC clock. This is an NXP LH or LP 02366. Yeah, LPC. And here we see the programming port. This would program this chip. Here we see the interface to the LCD. This is the interface to the print head. This is the interface to the motor, and there should be. This is probably the motor driver. These are the buttons. I don't know what this is. 271. No, a huge diode. This is probably a motor driver. It's next to the motor pins, and this probably can't drive the motor directly. Yeah, nothing interesting. Up. And what I was saying is this is just an LCM 1602, probably. So this is just a, oh, is it written here? Oh, wow, 2402. It's just an off-the-shelf LCD module with an HD 44780 chip, very probably, which, yeah, it's just an off-the-shelf LCD module. But instead of 16 character, which is the most common one, it has 24 characters. Oh, it's a bit larger. I will definitely salvage. I love these LCDs. They are very simple to drive. Well, not that any microcontroller can drive it, and you can display text very easily. They are cheap, they are very robust, and they are very readable. You don't have any font issues and so on. So I really like these LCD modules, and I will keep this. This is weird, soldering tabs on the shells. Yeah, this is larger. This is probably, oh, there's no backlight. Normally you have backlights on the side here, but this doesn't have backlight. Not that much of a problem. They work well also without backlight. It's very readable. I like these microcontroller. I like these LCD modules. And that's it. Nothing that interesting. This is plastic. Plastic where it belongs. This is just a printer. Can I? This is to remove it. Yep. Let's see the thermal printer. I can't reuse the thermal printer because I would have to use the complete case, but the case is too large. Up. This is the printer head with all the segments, and then they just roll the paper and burn the parts on the paper. And I don't know how many lines there are, probably something like 384. I don't know, but you see the individual traces. If this makes focus, you probably can guess the individual traces. Yep. To enable the individual pixels. That's it. Up. I won't use this. This is done. This is salvaged. This is plastic. Everything here is recyclable. Plastic and metal. They will crush it. The motor. So we keep the motor and we keep the LCD. That's it. We don't keep the paper. And now the main task. After 1 hour, let's have a look at our main toy. And it's probably, so we've seen already two analyzers, two medical analyzers. One is for hemoglobin, which just uses green and infrared LED. The other one is for urine, which uses orange and green LEDs. And now the last part, let's see if it also just uses LEDs. And that's the main part of the video. This one. So again, up. Afinion AS100 Analyzer. Is there a date? No, 40 watts. We use a bit more, but it's really heavy. I think I have a or power supply with it. No, I built a power supply with it. It's not the original one. 24-volt power supply. So this should still work. Let's switch on the power. Let's add the interfaces. USB, but not device USB. This is probably the device. This is probably the device USB, but the option is not here. Here we have I/O serial. So this is the serial output to read the measurements. Power input, 24 volts DC, and 2 USB host ports. So you can probably update it this way. So you need a chip which does USB host. So it's already a huge chip. And also, it's not an LCD. So on the first one, we just saw a very common LCD. On the second one, we saw an LCD module. This is not just to display digits, it's also to display text. And now we have the upgrade, which is an LCD. And we see it's already beefer. So it's a good stream to show the evolution. And now, can we switch it on? Yep. Okay, pro button switch on, it turns on. And I did ask for samples. What is this? Oh, this is something else. Up. Yep. And it did ask if there were some samples. So these are completely used. These are used and cleaned. These are not original samples. How does it work? So, yeah. I don't know what CPR stands for. This machine probably self-test. Okay, test itself. This machine probably can do a lot of measurements, blood measurements, and other kind of, probably other kind of fluids measurements. So you put your liquid in here, which will put it in here, and here we have 3 different chambers probably with some predefined liquid. Then it mixes this with the other ones and then measures the color. There's a second chamber here. Can I open this? How does this work? Can I? Let's check. Yeah, there are no liquids anymore, so I'm not afraid of it. Ah, here. Oh, okay. Okay. So here you see there's the aluminum foil, so there are some liquids already inside. And here, this is the barcode. This way the machine knows which thing it is. So there is already a barcode reader, a 2D barcode reader, 2D barcode reader. Because it makes noise. Just on one side is not enough. So this is probably where you put the sample. It closes here, and when you press on there, there are some clicks. Okay, there's first click right here, and then there's, no, it's not the second click. Or does it have to press stronger? I don't know. Because there are 2 notches, I would have guessed that there's a second click. But how does it do? Ah, this is the pipette. Okay. So you take the sample of probably blood and other kind of liquids. I'm sure this can do a lot of tests. So you take the sample here with this pipette, you put it on here, so it goes to this tissue, and I don't know what this chamber is for. This one, I don't know. And I don't know how the liquid from here will travel to this chamber or this chamber. I have no idea. Ah, probably, I don't know. I could have looked at the manual, but probably the manual just says how to use it, but not how it works internally. So this is still in test mode. Yeah, but it presses. Oh, okay. Does it use? Here there's some kind of gasket, so maybe when you press on it, it pushes the sample out on this paper, and then it measures the sample on this paper. CPR. Let's have a look. Let me have a look if I find some documentation on what CPR stands for. While this boots, it is loud. There are plenty of motors turning inside. Okay. Oh, you have. So these things wouldn't be the issue because this is this DC, and then on this side there is just an AC plug, but with 2 plugs. There is no earth connection, and what tripped was the RCD. And without earth, this should, well, it still can happen though. Yeah, it could still happen because of this. No, I don't know. I don't know. I don't know what tripped the RCD in my whole flat. But we were looking for the device for some documentation. Sorry for the 2 interruptions. Data projects to do Afinion AS100 documents. Website, no, documents. So manual US. Let's have a look at the manual. Let me switch to the screen. I found the manual meanwhile. Full screen. On the full screen we don't need, well, actually there's a lot that we don't need. We don't need this. We don't need, where's the other one? This. So what does it say? Operator, how to operate it, but I want to, well, these are all the buttons. Cartridge, okay, here we have it. HB, HB1C, so this can also measure the content of iron in the hemoglobin, or the hemoglobin in the blood. One, for collection for patient sample, exactly. So this is the patient sample, which you put here. Then we have 3 chambers. This is the barcode. 4 is the handle. Okay, 6 optical readout. So this is where the readout is. Okay, so I get it. You have plenty of samples here. Now let me switch the other camera. This. So this manages to open this. Then it uses this thing to get the samples and put that in the different chambers, or get the different liquids and mix it here. And we have plenty of room, or plenty of samples, so we can mix it in the different ones. I think this is how it works. And here is kind of the readout area, or the mixing in the end. I don't know. Okay. Let's read a tiny bit more. 6, yeah, 3. What is 3? 3 reception wells. Contains all reagent for 1. Okay. Maybe there are even some reagents here. How the system works. There's not a lot of test features. Internal process, self-analyze, self-fail. This machine works, but I don't care. I will break it. I just want to look at it. Here. Not in use. Okay. This is a test, and this is how to operate it. We will operate it immediately and see how it works. But I also had some documents, the cartridges, analyzer, HSTM connector. What is this? This is something else. Protocol. No. So yeah, this project was lying around in my to-do list, website video. Does it say the different cartridges? Okay, let's see. CPR. No, CPR, that's nothing. What? CRP. 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 No, it doesn't know CRP. Maybe in this CRP. Here. CRP or liquid panel. Okay, so these are the arrows. So it does 3 measurements. CRP, now whatever it is, HB, A1C. HB is for hemoglobin, and then A1C different ends, and then ACR. What is CRP? CRP analyzer. What is CRP? Reactive protein analyzer. CRP. Hematology analyzer. What is then CRP for? C-reactive protein. Okay. C-reactive protein analyzer, commonly known as CRP, infection. Okay, how much infection you have, probably. Yeah, probably the CRP. What? Here. A CRP test measures the level of CRP protein in your blood. So this is the blood. Your liver releases CRP in the bloodstream. This is for inflammation of your liver. Okay. This is what it was used for. So let's try it out. Okay, it opens the cartridge. Let's put the cartridge in. Let's put it. So now it verifies the cartridge. There's some motor, so it probably pulls the cartridge. The motor makes a lot of noise. Now it verifies the cartridge. So the machine works. Information code 209. We did have the code here. What is 209? 209. Let's have it in English and not in German. 209 cartridge. Test cartridge has passed expiry date. So it knows the date. So the date is encoded in this thing, and it knows it. it knows the date here. So let's cheat and say that this machine, this is something else, cassette einlegen. Okay, I don't care about this. Here, menu. Let's change the date. Date. It thinks we, yeah, it has pretty much the, wow, the clock is almost on spot, 27/11 November 2022. This is what we have. So the battery of the internal clock worked perfectly without having this machine operated. So let's clear it out. From when is this machine? Is there a date code on the bottom? I don't want to turn it around. Is there a date code on this manual? You don't see what I'm, so date code 2017. So let's say we are 2018. And let's cheat to, okay. How do I modify it? 222, okay. 28, no, 2, 2, 2. Okay, now 2, 0, 1, damn it. That's not a valid date, but 2, 0, 1, 8, 0, 1, 1, 0, 1. Okay. Now the date should be fine. So let's try it again. We don't know, we don't care about the time, the clock. Let me show you the bench. So back here. Let's put this. Now it thinks we're in 2018 instead of 22, so it shouldn't complain about the date. So there is even a date. Let me check what kind of 2D matrix code this is. If it's a common one. No, my code scanner doesn't recognize it. Now it does the CPR. This works. Is it probably? Yeah, you can almost see the angle. So it is performing the CPR. So I cheated on the cartridges. Exactly. Yep. This is how I cheated. You see, there were the two levels. The first level is when the cartridge is new, and then once it's finished, it presses to the second level. And the height of information code 201. Okay, and the height of the thing tells that there is something wrong. Now, what is 201? Let's have this. This was 209, 201. Up. It's in plenty of. I want it in English. Test cartridge 201. Let me show you. This 201 means insufficient sample. Okay. So up, and yeah, you see the cartridge now is on the second level where it was higher. So it uses this thing to figure out the height of the level. Okay, now I removed it and now it's as new. What if I put some red water? I won't put any blood in it. I don't want to injure myself, but what I can do is, if I find it again, damn it, where did I put it? I had some food coloring. Where is the food coloring? I don't remember. Here. And we can actually play with food colors. Yep. So we have a bit of food coloring. What is red? This is red, but maybe this is a bit too red. Let's try with this red. Do I have some pipettes? I did throw away all my pipettes a few days ago, and now I need them. Very useful. Don't I have some spare pipettes somewhere? Ah, damn it. No. Why did I have to throw away the pipettes? Oh, are they still here? No, I did throw them away. Okay, let's do it the hard way. And let's put a drop inside here. And drop. And let's add some water. Water. Let's mix everything. So it does some security checks. That's already a good sign. Let's close the food color. Now let's mix the color with the water. Looks like blood, doesn't it? Yeah, looks like blood. So let's try if this machine works. We will do, promise still, we still will do. So here we have the first level. We have plenty of liquid, of red liquid. Now what does it say? Beep, beep. Oh, this was fast. 208. We will have all the codes in the end. Test cartridge previously used. How does it... I get it. Oh, this is really clever. Within here, there's it tells what kind of battery it is. It also tells there's also a serial number, and it remembers the serial number it used before. So we do have, this is starting to get really clever. Can I clear everything? Factory, can I make a factory reset? Is this factory unconventional? Yeah. Okay, now this should be a factory reset, so this shouldn't know that the device has been used. I think it doesn't remove the calibration. So let's try it again. That doesn't complain, so yep. And now it does the CPR. It takes a bit of time, but it's not complaining. And we'll see what... Okay, it is complaining. Maybe we'll try to see if it did something. Okay. Give me the cassettes. Hup. Why does it say there's not enough liquid? There's plenty of liquid. Maybe there's liquid in these things. It probably knows if there's liquid in here. So up. Oh, I closed it. It didn't retract, so it can't figure out if there's something inside here. Menu. Let's delete everything again. Parameter delete. Yes. Yes. Can I put it to English? No. Okay. Let's put it in German. So let's put some food coloring in the other buckets, probably the 3 other ones. We'll add some blue. Just for it. Yep. Up and up. So I've added some blue color. Let's add some water. Lots of water. Lots of water. lots of water. And let's mix everything. My finger is blue. So this is very blue. I don't think there was something here. It probably does the measurement here because there was no seal, so the predefined liquids are probably here. But we will find out. Tack. Go back, go back, go back, up here, and now you can start the measurements. So this is how we call hacking the device. What we call hacking the device before we take it apart, so it works perfectly. But I think this is too old. I don't know. Nobody wants it anymore. I don't want to sell it. I'm just interested in the device. Now it does the CPR. Probably for you a bit hard to see. Is it this way easier? No, same thing. I don't want to tilt it anymore. Not while it does the measurements. There are liquids inside. I don't want to spill everywhere. If it says 201, then we will. It's done. We won't continue trying to trick it. We would need cartridges, and I have no idea. Okay. It doesn't want to. But we've seen the basic principles. Why does it say not enough? There's plenty of inside. Maybe the device is broken. This is why I got it for cheap. Tack. No, I didn't try to make any measurements. Let's add more water here and then a last time here and see if it does something. But I don't expect it to be able to do anything there. Yeah, let's just add some more water. Okay. Menu. Clear. Yes. This. Yes. Erase all data. Come on. Let's add a tiny bit more water. End up in fake blood. That's it. We filled it a tiny bit. Then we will add some color in here in the end. And this. So 2 tests, and then we will continue. We will start tearing it apart and see what's done inside. But at least we know that it measures the height. It reads the barcode. The barcode has a serial number, some identification to know if it's CPR. It doesn't really read CPR. This is human readable. Up. Tack. Tack. How does it detect? Ah, I see. Yeah, there's a light sensor on the back here. This is how it detects that there's something. Ah, see? When I put it, the text changes. Here it says, please put it in the cassette. And here it says, please close the lid. And in the back there was a infrared barrier. There is no power switch. Ah, no, there is. It's this one. But it's a soft power. It's not a hard power. Now it does a CPR. Will it complain? Will it not complain? What color do I have? The last one is yellow. Up. We'll try with the yellow in the last cassette. In the last tray, mixing tray. To see if it complains about that. Ah, my fingers are turning blue. My fingers are turning blue. So, who wants to talk to me? Plenty of people. Information code 201, yeah. So let's just test with the yellow, and if it's not working, it's done. Up. Clear, menu. And there's a touchscreen. That's nice. Yes, configuration, data management, yes. So let's add some yellow in the last thingy. Up. This is very yellow. Maybe a bit too yellowish, maybe too much. How can I sponge? I know. Here. Let's put tissue to try to absorb, to reduce the quantity. Okay, quantity reduced. Does it know because of this pin that there's not enough fluid? Does it try to push it all the way in? So maybe it is just because of this thing. Is it? Do I have one which is not used? Yeah, maybe. Let's put some tape on there. Let's re-put. I don't want to blow on it because I don't know what it has been used for. But I would like to. No, it doesn't look like this. They look the same. No, they all look the same. So let's put this back. This clack. Back, back, back. Counter it. Inside. Close the lid. Up, and now it does the check. This is the last check. If this doesn't work, then we will just tear it apart like we've planned 2 hours ago. CPR. I think it will still tail 201. What's your bet? Yep, 201. Maybe this unit is also the defective. That is possible. I don't know. But we'll still we'll tear it apart and we'll see what's inside. It's still a lot fancier than the 2 things we've seen previously. Okay, take the cassette. Oh, but it looks really nice. The colors look nice. I will keep it as souvenir for a couple of hours. So let's switch it off. Yeah, this is not a hard switch, you see. It's still doing the motor clean, getting into place. So this is a soft switch. There is no hard switch, which I find weird. Oh, this is so heavy. Plenty of screws. Yep, plenty of screws. And there are screws. I don't think feet hold something. I only think these are the right screws. Do I have the right screwdriver? This is quite a large screwdriver. Yep, this one. Yep, it's the right one. Where was the screwdriver for that? Screwdriver. Screwdriver. Where are you? I lost my screwdriver. No, it's not here. These are the small screwdriver. I wanted the other one. I do have other screwdrivers, but I wanted. Well, I'll have to use the other ones. Up. I'll find it at one point. But let's use this one for now. Yep. So 1, 2. These are holding it too also, but this is not the right bit, and do I have the right bit? Yep. Up. How no, I don't think the feet are holding it. Okay, but it's the right bit, but my screwdriver isn't strong enough to turn it. I need a stronger screwdriver, so this is a weak one. Let's get the screwdriver, another screwdriver with the right bit. I need to find the right bit. Is this right? It fits. Plenty of torque. One. This time let's mark it. I'll probably put it back together. Sekunde. So, let's remove the blue color. Let's put this mat and let's mark where we got the screws in case we want to put it back together. So, bottom left, you're not seeing what I'm doing, just marking the parts, and then bottom right, bottom right. Ah, damn it. These are these two screws, which we use the screwdriver for. One and two. Bottom right, and they're long. Ah, there are two here. I'll count it as bottom. This is probably one also. I kind of have the feeling this is also one. I wouldn't put just 3 of them. There are no screws here. There are no screws here. The feet are probably also screws. Let's unfeed it. No, that's not one. So the feet are not screws. Okay, so 3 of them. Can we? Yep. Can we? It is. Yep. Okay. 1, 2. Maybe it's, yeah. Expected there must be a screw on the back, but where? We saw that this was not. It was not the feet, the 2 grills we did remove. So where is this screw? Where is it? It's not on the side. It's not the feet. Let's remove it. I don't think. No, this is definitely not it, but. Ah, yeah. Now I get it. Tamper resistance. Or tamper resistance. Just to know that somebody opened it. Yeah, tamper resistance. Somebody opened it or not. Yep, it feels like it. Up, so let's break the seal and open the device. Yep, now it lifts. Ta-da! And we have a lot of machinery. I really didn't expect it to have that much. This is a lot. Let's unplug this. Wait a minute. Let's unplug this part. This is just the ribbon cable to the touchscreen. And this part, this is so. Let's have a look on this part. Okay, this is just more than the ribbon to the touchscreen. Here we have a PCB with a super loud buzzer. Never seen such a big buzzer. There are also, yeah, the two lights. The two lights are controlled by this PCB. We have coils for the buzzer, I don't know. We have everything. This is the touch screen. This is the backlight. And so this is the LCD and this is the touchscreen or backlight. One, yeah, this is probably the backlight. This is the touchscreen because here we only have two lines. And here we have a solenoid which closes, yep. This closes, you see the mechanism, it holds the lid shut using the solenoid. And by default, the solenoid prevents you from using it, yep. And if you charge it, it goes against this spring. It allows you to open the door. See, by default closed. If you charge the solenoid, goes against the spring and it opens the lid. So that's on this side. There's still plenty. Maybe there's a, I don't know what, there's so many things in here. But yeah, it's not too much more. No, this is huge. There are plenty of gears and motors and whatnot here. This will take a bit of time. This is the main PCB and this is a T-sub connector, very often used for flash, no flash. Oh, you already see kind of a fuse holder, a tiny fuse in kind of SMD format, which you can change. This is the ribbon to the display. Here we have a crystal. This is very probably to keep track of time. Here we have a huge battery, and this is why it still has the time. CR2430. I've never seen this battery. Again, a fuse holder with a fuse inside, which you can change. And plenty of things. Oh, we can also see the inside. Where do I have to start? There are so many things in here. There are really tons of things. Ah, here we see. This is the bar for probably the cassette holder. Ah, now I see plenty of things, but it's harder to see. Can I move it? This is the cassette grabber. Why can't I move it? Doesn't this? No, this should move. This whole tray assembly should be able to move forward to grip the cassette. Oh no, no, it's not how it works. Nah, okay. This does it. Ah, okay. So this motor turns this. This presses. Ah. Okay. Ah, it turns it open, and then when it continues turning, it's here. Whoa. There are two actions actually. When it turns, it lifts this mechanism. We'll see afterwards what this does, but it also turns this mechanism, tack, which snaps. I think this snaps the cassette. You see, it opens the clamp. Tack. I think it's holding the clamp and then pressing something inside. Wow, there are so many things on this thing. Okay. Who is the tray for the cassette? Can all this thing move? Yes, it can. How can I make it move? You see, I'm making this screw shake a tiny bit this wheel on the back, this one. But it's holding it back, so something is holding this whole assembly back, and I don't know what is. It's locking it. Who is locking you? I want to unlock you manually. But it's a mechanical switch. I can try to take apart all the things one by one. Oh, switch one. Ah, this is the soft start button. Actually, we can even try. No, the display isn't there anymore. If we could display. Does it know that we opened the device? Can we try to operate it while it's open to see how it works? We will try. So the ribbon cable goes in here. Tack, tack. Up. This is just a solenoid. I don't think it measures back the solenoid. So let's plug it back in. Power is on. I don't want to touch anything. Up. It's not on. Let's press the button. Yep, it switches on. You don't see the screen, but I'll tell you. The screen goes on. I've lost liquid. Thankfully, it's just, yeah, I've lost this liquid. So let's switch it back on, and let's see what it does. Okay, now it does a self-test. Will it so now it didn't complain that I opened the device. Will it detect that, for example, the solenoid, which is holding the lid, is not connected? We will see. But there is a way. No, there is a way by detect that it's closed. Where? How does it detect that it's closed? This switch. You see on the back here. There are two actually. I can also plug this back in. Yep. There are two infrared barriers to figure out that the lid is closed. We can actually connect back in. Oh, there's a port which I didn't use here. There's a connector which is not used. Still does some self-testing. That takes forever. Oof. I don't want to touch anything while it does the self-test, but yeah. This way it finds out. Oh, we see there's a kind of activity. Beep beep. There's something it doesn't like. Geräte nicht offiziell. Okay, it knows that it's in a not operating modus. Because it's open? I don't think so. Maybe because I tweezed. No, I just turned this. I didn't change anything else. Let's just switch off and back on. I don't think it knows that the device is open, else it wouldn't have started any motor. It would have identified immediately that there's something wrong. So back on. I didn't disconnect anything else, no. Maybe it knows there's too much light coming in. Let's close this first. Once it finishes the testing, we can still open it. If it still works. So let's try to close it. Okay, this is like if it would be new, almost. It's not completely closed, but I hope it's enough for the light to not come in. We'll have to wait for the thing to start. Put the food coloring back in the tray and try to figure out where the screwdriver is while it does all the self-check. These are my keys, screwdrivers. Batteries, they go in the battery bin, which is here. Although they were, no, I think they're too old. I won't use them. I only have rechargeable ones. Is the screwdriver here? No. Okay, now it starts. It's already going further. No, it's not. Okay, I did change something which it didn't like. Okay, not the problem. I didn't want to keep it this way. And we can have a look at all the parts. I don't know why it doesn't start. I don't care. Let's take it apart. Okay. So we know about that. Let's see all the parts. These are probably pumps. We see here there are some tubes. Let's zoom a tiny bit. There are some tubes here, here. This is a pressure sensor. This is probably a motor. And this is the thing which is going to the sampler. And then there is here on the back there's a chariot. Why is this? Can it press on this? Oh, it moves. Now it moves. Probably this is why it complained. I get it. Okay. When it goes here, you see that it presses a lever up, which closes the view. When it retracts, the lever goes down. And what for? This is a good question. I don't know what's important for the lever to go down. But this is able... How does it hold the sample? This is the sample. It doesn't... Okay. It doesn't... Okay, it's this way. It's easy how it holds the sample. There is a keying here on the front. This is a bit larger. It just holds on that, does it? Yep, that's it. Then it goes down. Check. Check. Okay. So this is how it works. This is how it holds it inside. Oh wow, okay, now I see some other things. Oh, it cannot lift the chariot. So, it can. On the side here, let me show you. Here on the side there's a lead screw which can make it go up. Oh, it can make it go up and down. We can use a screwdriver to simulate it. Screwdriver, this one, to make this. So let's remove the sample. We don't require anymore. We know how it holds it. Can I move it up and down here? No. I need to go to this window. And if I turn on this thing, yep, it moves this chariot up and down. And I think it moves it up, so it can grab and snap on that. The snapping, the strong snapping, and this is what presses on it, and the hardware all at once. It snaps on the side, so it holds back. We see the keying also. Here, there are two pointy things. They are very probably going in here and in here. Yep, front and back. Yep, they are holding the sample together. These two things are holding the sample together. And I think this, which snaps when we turn it, clack, while the sample is held, it will press the thing down. Yep, I think that's all this mechanism. This is how it presses it down. Now it does plenty of things to measure the quantity and so on, and I see plenty of different things. Here we have on the back, there's a whole strip of LEDs, but they are not your usual LEDs. They are probably LEDs, but they're not your usual LEDs. They are on boards and then glued. I don't know what for. On the other side, there is also, think like one of the tubes you see in scanners. And on the bottom, I think it can move the cassette on the bottom, and here we have sensors also to, this is to heat up. Wow. This is to heat up the thing. Let's take it apart. I won't put it back together. I'm not interested, and it doesn't operate anymore, so, and I don't want to fix it. So I don't care where the screws are going. Let's just take it completely apart bit by bit. This is just, oh yeah. So on the back here, this is soldered on. This is not soldered on. Oh, there's only one. Okay. This is a retroreflector. So on this side here, we have an LED emitter and receiver. And when it reflects back from this side, it means that there is something in front. And this is how it knows that there's the cartridge. That's this part. This is done. Up. Next part, there are plenty of things in here. Let's take this side. What is this? Is this to heat? I don't know why there's so many pads on there. No idea. Let's open this. Screw that tons. Wow, this one is heavy. It's hard to turn. There are tons of chips in this one. Sub 8 packages. What for? I would say no, I don't know what. They're all the same. They're probably motor drivers. What is this board connected to? Oh, they're not all the same. But focus on that. No, they're not all the same. We have plenty of 364. These two. 364, 335, and then we have an ST9 S02, I don't know, maybe a microcontroller, IT PCB, interrupt PCB, but this is connected to, okay, it's connected to the main board, so I don't know what it does. Oh, I didn't see it. Here. Probably one is a temperature measurement, and this is an infrared receiver, IR9902. Very probably an infrared receiver. Or to measure the temperature. This is a temperature measurement board probably. And this way it can measure the temperature of the liquid without looking at the liquid. So we have some heaters. There are heaters, they are on the bottom. These are heaters. I saw the PCB structure. So yeah, this is a infrared temperature sensor. Okay. It can't be expensive. Let's put it on side. I don't know if I will cook, but this is probably to measure the temperature. My guess. So this cable. But the processing is done on this board. Up. Let's remove this cable, FPC, that's done. This also fell, I don't know what this is. Oops, I'm already losing parts. Let's continue tearing it apart. This PCB. This is probably just to control the motor. There are two. They seem identical. There are probably pumps to mix the different liquids. So peristaltic pumps with whoa. Upboard we don't. Here there's just an up to infrared barrier, and this was here, so it figures out how much in this motor. Here. This black metal piece goes back and forth as the motor turns. I can't make it turn. What kind of motor is it that I'm not able to turn it? And this is probably to calibrate the start, and then it knows how much it can measure inside. Let's check how much it can push inside for the motor. Let's disconnect this thing. Up. Let's move the two. One, and so this is only going on one side. Oh, this is something custom. It seems like a pump. Oh, damn it. Why is it holding? Okay. So the motor turns this in and out. Can I turn it by hand? Pliers. No, I'm not. I'm just turning the screw. What is this? Is this just a pump? There are two coils. I don't think this is a stepper motor. No, it's just a 12. Bye-bye screw. It's just a 12 volt motor. So because it's not a stepper motor, it needs to calibrate, and it goes back. There's some more than just one. No, there's just one. It goes back to home, and then it knows that if it puts 2 milliseconds, it can forward that much. And I think this is just a pump. So there's just an oxygen, and it presses inside. But we can have a look. Damn it! Again, break one of the screwdrivers. I need something harder. Let me check if I have a bit for that. I used to have plenty of bits. Up, 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 up. Bit set. Probably something which is holding it better than my cheap things, which are not meant for hard metal. This one? Maybe. No. Smaller. This one. Yep. Up. You go back on here. You go here. And now we can unscrew you. So I think this is, yep. This is just a pump. So it pushes in and out, and it's just enough to take the fluid in and probably push the fluid out in the different things. Yep. This is just a pump. Or a pump, a syringe. Yeah, a syringe. Up. Exactly. Here we have the tube to see the progress, and probably so it fits perfectly. Oh, it's so smooth. You can't feel it, but the inside is so smooth. But this motor turns the piston, and then this makes a tiny syringe to push and get fluids, and I don't know how much money they spent on custom parts for just having a syringe. I don't think these are serial produced things that would have cost plenty of money. Okay, let's take the other thing apart. Okay. Here. This is the next part of the syringe. This is the needle. This is probably what's putting air inside and out. And it's going in. It's either here. Yeah, probably. Yep, here. You see, it goes simply here and then it seals back. So it's probably getting. Can it go here also? I'm not sure. But it can definitely pierce this thing. One, two, plenty of screws. This why? This is so there's this mechanism. They are so tight. And this is not the right screwdriver. And I'm breaking my screwdriver. I don't want to. I have one smaller bit. Where is the plier? Let's take this one. Up, up, up. Yep. This is made out of a harder metal. So. Come on. Okay, don't know why I removed this. So I can have access to this screw. Okay, this is this assembly. Up. Up. And can I get this assembly out? Yep, I can. Oh, okay, this is just to grab cassettes. If I have one. Use this way. Check. Oh, there's a pin which presses in. There's this pin which pierces inside. Does it? It's fixed. I don't know how this goes inside here. There may be some. First it goes here. This way it can up and down, and then there's a second level. This is, yeah, there's a huge needle, matte needle. So first it just tries that, probably to snap it on. this go here? No. This can go this way. That's okay. It can slide all the way here. But you put the cassette here, it was this way. So yeah, this needle really pushes inside there really hard. And this was the front needle here. So this front needle pierces not the back plastic, but actually the front. Okay. And you need a lot of, now I know why it needs to hammer in. It needs really a lot of force to push this damn thing in. Okay, I don't have the force. I think the spring does the mechanism, but it, now it goes here. Sorry, this is just to hold here. Nah, okay, now it doesn't need a lot of force. Okay, now it holds it, and then it can press, because it holds the back differently. It can press the thing inside, and then the needle goes actually in here. So this is where the needle goes. Yep. Then it can absorb the liquids. But how does it get the liquid in the different? I get it. No. Do I? It never mixes. It never mixes the liquids. Maybe it mixes here. I don't know. But here, these liquids are reference colors. Very probably reference colors. This way it can calibrate the machine. Because there is no way. There's no way that it can get the liquids here. So these are just reference colors. And it probably can just get the liquid from here, put it here, and put it in some kind of filter. But it cannot mix with the different ones. Yeah, 3 reference colors, and then the liquid can get absorbed here, probably put here, and then through a filter, which only gets the part which we want. Probably like that. Don't know. But no liquid mixing. What is this? There's another pump here. Let's try to get this one. Okay, what is this board doing? Okay, this board is just referencing if the... yeah, this board only has an optocoupler, an infrared barrier to verify when the wheel turns. Where is the wheel? Which I threw away something. There was the plastic wheel. This can get removed. Here. This plastic wheel has these indexes, and this was going through the infrared barrier, and this way it can figure out when it snaps and so on. And that's the only purpose of this PCB. And it has some neat cabling, see? Cable holders. This is the next board. I'll just remove this board first. And this is old plastic, very brittle. Okay, so this is removed. Now I want to have a look at this thing. Up, up. Okay. There's a screw on the side, but I don't know if it's to hold it or if it's just so it can rotate. No, it's to hold it. They even put some kind of Loctite on it, this white powder, I think this is so the screw doesn't get removed. 1 and 2, there are the 2 springs on the side which make the action. And there, okay. This probably also snaps on the front. Yes, it fits perfectly. And it can, yeah, only on the front. And this is, here we have the same mechanism. We have an infrared barrier with this motor which puts in and out, and I think this is just to put some air in and out, or to put some, yeah, probably to get a bit of the sample inside. So it probably either it pushes air in or it draws air. I think it draws air, so here is the sample inside. This is kind of a pipette, and it draws air through this filter. This is probably just a filter which can let air through. But what for? So here it has liquid, but it cannot put the liquid anywhere. Oh, can it go through? Yes, it can go through here and put the liquid inside. But then what is the syringe for? I don't know. And what is this small device on top? So this is the motor, 12 volt again, and this is probably just a pump to put some air inside and not a syringe. But what is on top? A valve. Very probably, yes, here we see the output. This is a valve to let air in so it can build pressure and it can then remove the pressure. So it can push here, it seals, the valve closes, and it can either create vacuum or put pressure or create pressure. Does it do anything when it creates pressure? And the valve can then reopen it again to remove the pressure. I don't know what you would do. Probably it's just to suck air. So it can suck a bit of liquid in here and then can probably put it there, would be my guess. What is the syringe for? I don't know if it can do it this way, but it's very clever because then you don't need to clean the syringe. You just always use this dispensable part, which is also a syringe, and it can really pierce through. See? No problem piercing through this to this membrane. And then it can put it through the filter. This is probably what it, okay, very clever. So this is the reusable syringe. I don't know what this syringe is used for. It probably afterwards goes in here to create pressure. Maybe to create pressure so the blood goes through this filter in a controlled fashion. Well, maybe. This could also do the trick. But again, just a linear motor. Okay, that's that. Now we have this on the side. What is this? So this is canned. It means that it is something, there's something inside which it needs to protect from light or from radiation, or both. I didn't remove it correctly. And this looks like a heating circuit. Okay. Light. You see how black this is? This piece must also cost quite some money. And this, how can I, is there a screw? There is no screw, so I should be able to get it. No, I don't see any screw. It's just clipped. On the side. It seems to be clipped. This is the barcode reader. Now I get it. This is like you see on scanners. Okay. This is the barcode reader. want you to move out so I can have a detailed look at you. Okay, there is this metal is bent. This metal on the back is bent. Let's bend it upwards on the two sides. This is probably an expensive process to have this thing bent. One tab. And the second tab. Okay, now it gets out. Okay, I think this is the barcode reader. We have the chamber. Yep, we have. Yeah, this. I think this is it. We have this chamber which was closed. This probably. Okay, I don't know what this is. There was nothing in here. What the hell is this? 4 ohms? I have no idea. There was this. No, this is nothing, something else. Where's the metal piece? Here, this one. There was this metal piece for a chamber, but why would you want a chamber like this? And why this white reflector right there? It's not connected to anything. It's like just for heating up. I don't know. Let's see what's inside here. I have no idea what this is. I would have guessed that it's at the right height. This is the barcode scanner, but you wouldn't need to emit light and to receive light, and for that there are not enough connections. Okay, no, this is the barcode reader. This is probably, this is kind of a, whoa, this is expensive. Whoa. There's one filter here. There's one another diffusion filter just right on the back. I don't know if it's just polarization or not. And then we have, I think these are sensors or these are LEDs. Probably these are LEDs. Yeah, these are probably, wow, even the sides are made of metal. Let me try to show you. This is just the metal holding back everything. And the two parts. These are LEDs. These are probably, this is for heat sinking. I would guess this is metal for heat sinking. So these are LEDs. Plenty of colored LEDs, probably to shine through. And these are some diffusion. Yep, and you can probably see this diffuses light. These are plenty of LEDs, and if we can probably make them shine with the up. Let's check if we can with this. Let's just try any two combination. I need to switch on the power supply. Power supply is on 3.3 volt, 20 milliamps. Okay, doesn't show anything. Does it need a special combination, or are there not LEDs? But why so much heat sinking, and why so much diffusion? I think these LEDs. Come on. It's not possible. Nothing? Can't believe that these are not LEDs. There's a resistor, but it does nothing. Come on. Does this work? Yeah, 20 milliamp, that's okay. But it doesn't draw any energy. Maybe. But white LEDs, let's switch to 4 volts. I don't care if I break the LED. It's more complicated than I wanted. Come on. Just want you to shine. What is complicated? I really have to figure out what is connected to what. I don't understand how it works. Because if you look at the traces, there's a trace going in here. This is where the filament is, and then goes to this metal plate. This metal plate goes nowhere. It's not connected. So I have no idea how they enable this LED. These seems to be 4 LEDs. Oh. What? What? This is... These are wires. They are plugged. So it's even surface. And they have probably the same thing on this metal plate. This is super expensive. You see these? I didn't think they were wires, but they are wires. They are just very flat. There's no hole you can see. They are probably plugged wires. This is super expensive. And probably they have the same thing here. Yep, here they have the wire, which goes to the next one. Okay, so you need to chain them. So very probably LEDs, but super expensive. Let's scrape just one LED. Just the metal for one LED. This one. So let's see if it works. If I connect this, let's put it back to 3.3 volts. Now should be here, and I never remember which one is plus, which one is minus. I still can't make it work. I don't think these are photodiodes. The diffusion wouldn't make too much sense. Oops, maybe I broke them. Yep, now I broke them, definitely. And having the chips on LED would have cost a lot of money previously. Now I don't think that's that expensive, but back then it must have cost a fortune. I can't manage to make them. So probably not LEDs, but maybe receivers. I don't know. I'm spending too much time on these things. $1.2 volts. No, these are LEDs. This is probably an infrared LED, and that's why I don't see it. Probably you can, maybe the camera can see it. Yep, definitely an LED. 1.2 volts, can you see something? This LED should be on. At 1.2 volts. See anything? Let's try this one, the next one. I'm removing the solder mask to have access to the copper underneath. Same. No, different. Here, yeah, there are LEDs. This is a red LED. I don't know what this color is, but these are probably red, green, blue LEDs. Let's try. Let's scrape the other sides. No. Sometimes I have the feeling I'm breaking the LEDs, or maybe this should be an LED, but it doesn't show any value. Maybe I broke it. And this one, it's between here and here. No. No. Probably broke it. I don't know how they switch, but yeah, we'll get this. I think these are LEDs. This is on the front are diffusion layer, and on the other side there's probably a camera, and it shines through the thing. I can't make the LEDs work, but I'm pretty sure that that's what it is. So let's continue with the teardown. Getting already a long video. Up, long screwdriver for the next part. Long screwdriver. Why did they put two different screws? Okay, this thing, if you want to come out, larger screwdriver. Perhaps it's the only one. Something else? No. Nothing else holding it back. Up. This thing is just a heating plate, as far as I can see. No, it's not just a heating plate. It must be more than that. Damn it. I want to use the electric screwdriver, it's just too loud. I don't like it for that. This is far more than just... So this is a rail which is mounted, spring mounted. That must cost so much money. What is this plastic mounting? Why is this so important for it? What does it do? For me, these are just heating plates. Let's try to remove the metal cage. Okay, what is this PCB doing? This is just, yep, this is just, again, one of this linear thing up, or one of this, how is it called again? Yeah, here. They again have a PCB just for an infrared barrier, just to detect when this chariot here, when this passed the right point. Just for that, they created a complete PCB, and they had to wire it. How can they make this machine affordable? I have no idea. Okay, there's still some screws holding this whole device. There are plenty of screws holding this whole device. And let's continue on top. Again, just a PCB to have some, just a PCB to have some traces, not a lot more, just for a button. This is so expensive. Something on the back. So this was to drive the LED. This cable here was going to the LED board, which gets diffused. Up. Up. With, they have to put just a connector with traces and plenty of other connectors just for traces. I can't remove the cage yet. There are plenty of other things. Let's have a look at this board. If it's really just the same mechanism than the other ones with LEDs on one side and then a measurement sensor on the other side, it's over-engineered. Okay, it must be samples, it just moving everything and so on. Diffusing all that it needs, I don't know, is it really required? Probably depends on the measurements, but it must make it so complicated. That's not a mass market device. Okay, can I now remove this? This seems to be the main board. At least there is only one. That's the beginning, which does all the I/O, all the calculation. We didn't see any other microcontroller, so this does everything. This is just a motor. This motor was driving this. This motor was driving the clutch switch. Bang. this is probably the camera because of the high pin counts. Right. This connection is going through this motor, which shifts up and down in chariots. This is so expensive just to move the chariots, to snap everything. It's a lot easier to have the operator do that, like on the other devices. Here we have cables for, oh, sorry, damn it. I just restarted. Let me change that. I always have to switch off this. This cable was going to the heating plate on the front. This cable, I don't remember, I've cut it already. Up, let's remove that. Then we have yet another cable which goes to yet another board with just an opto, an infrared barrier. And here this goes through another board with the LEDs. We'll move it afterwards, so we'll have a look at this afterwards. Let's continue with this. This is plastic which has been molded just for this part. Okay, so I still don't know how they read the barcode. Probably have a camera. Okay, just molding plastic. Whew. I don't know what it's used for. Just molding this plastic. Then there's this motor. We don't care about it. I will remove it. So this is done. And this a stepper motor? Yep. Seems like it. There are 4 wires. Yep, stepper motor. It's written on it. So here we've gained again a stepper motor. Up. This is very probably the camera. Can I remove this? Not yet. Here you see the mounting on the side. Just for this thing. Ah, maybe I can now remove the metal bracket. And why do they made it out of metal? 1 and 2. These are probably screws. Yep. Okay, we'll have a look at this thing afterwards. So here we have a NEMA motor, which is just there to drive that. And then we have this flex cable. Ah, here. So now I can remove this. Let's remove this. For me, this is just a heater. But we'll see if there's something more. You see these flexible PCBs, these are probably just to heat up. I don't see anything else. Yeah, this is just to heat up. This is probably a temperature sensor to measure the ambient temperature. Oh no, it's not a temperature sensor. You remember? We had this device to measure the temperature without contact, the infrared meter. This was very probably looking through this window to measure the temperature of that. This is maybe just a MOSFET to regulate, I don't know. So it's a 9502 SP, I don't know what it is. No, it's not a MOSFET, the traces are not good, are not big enough. I don't know what this is. But this whole thing with spring, so you can push, so the cassette can be pushed in without damaging anything, so they have a tiny bits of reliance. Just that is expensive just to heat up the samples. Okay, it's a sample heater. Here we just have a motor. This is to cool, I don't know what. I don't know what it cools. It cools something because they are fins, or maybe it looks good. I don't know. No, it doesn't cool anything. Here we have a flex PCB going down here, being folded and going to this motor, which is actually the up and down. What? Why do they have a heat heatsink here. There's nothing attached to it. It's just to cool the sample. There's also a pin right here. This is probably for this whole, I don't know where it is, chariot which was moving back and forth. It's a mess on this desk. But I don't know why they have this, maybe to cool the sample. I don't know why they have this such a huge fin. Let's check if there's something on the back. And why are there this plastic tubes or nylon thingies? We didn't see all the DC to DC converters for all the motors, so it's probably on the main PCB. But first, let me check if this heatsink is an overkill, or if it actually does something, or it just looks nice. Okay, there are plastic springs which won't make just spring it as stronger. Okay. Okay, so it holds the sample. This is really to cool the sample. Then it goes somewhere here, it goes down using the other motor where I turn this. And yeah, this is to cool. This whole thing is to cool off once it's heated, to cool off the sample again. Oh. So they need sometimes to cool, heat, cool. Maybe they need some cycles. I don't know. Just to cool samples. How much is this worth? Just to cool samples? I don't know. Then there's this linear thing. Up. Which is clamped on the side. So there's the flex cable for the motor. Again, yet another screw. Kidding me, right? Let me break it. I don't care. Okay, here we just have a linear thing. So yeah, this is just a motor, but there's a board here. Yeah, the board again, which just an infrared barrier to figure out where the motor is. But I'll keep this stepper motor, 1.5, 1.8 degrees, as teeny, small, useful motor. I'll keep also this motor. Let's have a look at this. So this is again a board, probably just, these are the LED boards again. Yep. So here there's no diffusion because there's plenty of space. So let me get this. Can I get this out first? Don't know. Here. I think these are again all LEDs. I don't know what color LEDs they are. There are plenty of different colors. Yeah, but can I turn them on? Let's try again. I will check the last part afterwards. My bench is really a mess right now. So if I clamp on one side, what happens? I'm just trying the contacts randomly. Just to figure out if something is shining. Ah, here. There was something. Did I make a short? Okay, this is a short. Just created it. Why is this so complicated to switch on LEDs? Ah, you can switch on all LEDs. See, this pad is for this LED. It goes here, but this is not soldered. This is weird. Why would they make that? Why would they populate the LED but not solder the thing on it? Let me scrape this off. And they're different colors, you see it from the die. But why would they make things so complicated? Okay, other way around. Come on. Ah, here you see red. There's a red LED, and probably the other ones are other colors. Just for LEDs, they have this board, and they had to put the LEDs into wire bond and to put some glue, and not all LEDs are enabled. Too much money. Over engineering. Really too much money. I don't know who can afford this process. Can't you just buy off-the-shelf LED and reflow them? This is not a super mass product. So yeah, again, LEDs to shine. I'm ready to have some other shining, and for me this is the camera. Yep, this is the camera, and this is also a custom built camera PCB. It's even written on it. This is probably seriously, to decode the code on the side of this cartridge, they're using a CMOS, and then they're using probably some FPGA, that would be my guess, or some super huge CPU to decode that and to do some machine reading. Couldn't you put a 2D linear code with super inexpensive scanners? You had to create a camera. This is probably also the camera which is calibrated to look at the colors of the sample. Very probably. So this is a very well calibrated camera for the colors, and they have the white, which over-engineered. Oh yep. Plenty of DC to DC for the steppers. Here we have, this is huge. Okay, let me zoom on it. We don't care about this. This is just DC to DC converters for all the voltages, for the motors, for the heating elements. This here is an FPGA in Spartan, so this probably does all the camera interface. This is the main CPU and ARM. This is a Samsung S3 C24 10AL. This is probably huge. This is probably RAM for the thing. This is probably some eMMC. I don't know. This is some Intel M24 90067. That would be my guess. This is some eMMC. This is a 2-port. This is a map sensor. One port was connected to the how is it called? To the tube, which was going to the syringe and to the head, and the other one is on the air, so it can measure the pressure on the syringe and on the head, and it can measure the on the air, so it makes the difference. So this is the main CPU. This is the clock for it. This I don't know. This is probably the RAM for the CPU. Plenty of things. and an FPGA. Over-engineered. This device is over-engineered by far. Just to read some colors out of some samples. Having custom LEDs, having a camera instead of the two other things which we saw. So yeah, it is flexible. You could program any kind of information. As we saw, we have only 3 kind of data, which is red. Make it simpler. For every device, make it a lot simpler. This is very, very expensive. And all the pieces, all the metal pieces and so on, all the assembly which is in there. They have even custom plastic, custom metal, they have rails, they have motors going everywhere. This must be so expensive just for measuring some blood samples. I wouldn't recommend anyone buying. This is too over-engineered just for a couple of measurements. The 2 other ones were great, very simple. Some LEDs, some sensor corresponding to the LEDs. You manually put the things on it, although the other one had a small motor to put it in, but nothing that fancy, that clamps, that puts pressure and so on. I don't know how hard it is to make CPRs and so on, but I would guess it is possible to do it a lot cheaper than that. But there we have it. We finished analyzing it. 3 hours of work. This is done. I'll probably, so this is, you could resell this FPGA if still somebody wants it, and this FPU, this probably costs more than the CPU. But what you can do is say in situ, so for anyone who wants to desolder this FPGA, it's on a board which was perfectly working. The rest you can't. I mean, this camera is just too proprietary, all the gears are proprietary. I will keep the motor, maybe the infrared sensor, that's it. And now there's plenty of liquid on my table. Yeah, but you've seen the inside of a blood analyzer and how much effort they put into it. Although it wasn't, I would, and you see the 2 simpler versions, and I would guess you could also, I don't know, I have no idea about the thing, but I think this is too much engineering. You could make it simpler, maybe not as simple as the 2 examples we saw, but probably simpler than having a PCB with your own LEDs, which you don't use them all. But that's it. So you saw the analysis, and yeah, I'm finished with that. So enjoy the rest of your day. Bye bye.